Hello everyone. Okay, so we are talking about data types and saying that we need to have a way to represent all type of numbers, right? We finished talking about integers, now we're talking about floating point numbers, in other words, decimals. All right, so we talked about doubles in the previous video. Now we're going to talk about floats. Right, so a float is also is the second type of floating point number. And so to declare a float, you just start with the keyword float, and then you give it a name. So I'm going to call this my first float, and I'm going to initialize it with a value. I'm going to say, well, before that, I always forget this. Let me just talk about the range of a float. Okay, so a range of a float is from plus or minus 3.4 times 10 to the power negative 38 all the way to plus or minus 3.4 times 10 to the power 38. I hope I typed this correctly. 10 to the power 38. Okay, so basically this is what a float can hold. This is the range of numbers that a float can hold. Okay, and so I'm going to go ahead and initialize a floating point value. In this case, my first float with the floating point value, like a literal. And so I'm going to say 1.6. Okay, 1.6, and then terminate it. Now I'm going to go ahead and use it in a system without a println statement and say that I just created my first floating point, my first float, and I'll just say my first float called my first float. Sorry, my typing is bad. I just created my first float called my first float, and its value is, I'm going to concatenate with the value of my first float this way. All right, so we would expect this to work, right? Because we've created a float over here. This is the range of it. We've stored a number, floating point number, in the float, and we are just displaying a message with the value of my first float. So when I compile this, see, we have an error. We have an error, and it's saying possible loss of precision. Okay, I think we've done everything right, but it's saying there's an error. We've declared this variable to store a float, and we've given it a value, and now it's complaining. Over here, you can tell that it's saying it found. First of all, it says what is required is a float, because we declared this variable to store a floating point number. To store a floating point number, in this case a float. Okay, a float. Okay, floating point numbers are grouped into two, doubles and floats. So in this case, we declared a variable to store a float. Okay, and so it's going to require that you store a float in this variable. So it's saying required is float, but it found a double. It's seeing this as a double. Okay, and that's a thing with Java. Okay, Java by default, anytime you write a floating point number, anytime you write a floating point literal in your program, remember we mentioned that a literal is basically a value in your program, a value that you write into your code. 1.6 here is a value. It's a value, and it's a floating point value. The thing with Java is anytime you write a floating point value in your code, anytime you write a floating point literal in your code, even regardless of the type of number it is, even if it's a float, even if you type a number, okay, you store a number in the range of a float, and you try to store it in a variable that you declared as float, Java sees that number as a double. I don't know why. It does the same thing for remember we talked about integers. Anytime you write an integer literal, it sees it as an integer, as an int, as the data type int. And so you'd have to specify what you really want. Okay, so anytime you write a floating point number or a floating point literal in your code, even if I keep on saying it wrong, anytime you write a value, a literal of type float, okay, in a variable that's declared as type float, even if the value that you are storing in this variable is of type or it's of a valid, I'm sorry. Even if this value that you're trying to store in this variable is of the type float, is of the valid type, or is of a value that's in the range of this, Java is going to, by default, see this value as a double. Okay, any floating point number you write, Java sees it as a double. And so if you really want to store, or if you really want to tell Java that no, Java, this number is not a double but a float, you'd have to specify it with a letter F, okay, at the end of it. Okay, because Java sees any floating point literal. If you write whether it's 1.6, 2.8, whatever it is, any floating point literal, Java sees it as a double, and so you have to specify that because this is it's a valid number to be stored in a float. You'd have to specify to Java that this number is not a double. Okay, so don't see it as a double, see it as a float, and you do that with a letter F at the end of it. You can use a capital F to do that. And see, now it's working. I believe you can also use the small letter F to do that, and now it's working. But use capital F. I mean, both of them will work. So, all right, okay. So I hope you understand this part. 1.6 is valid. It's a valid number to store in a float. But the thing is, anytime you write a double, I keep on saying it wrong. Anytime you write a floating point literal, okay, into your program, Java first of all sees it as a double, and so you'd have to specify that this number is not a double. Don't see it as a double, see it as a float. Okay, you do that with the letter F here. And so when you compile this and you run it, we can see that it's working. It says I just created my first float called my first float, and its value is 1.6. Okay, so that's all about floats. Floats and doubles are all floating point values. Floating point values are basically decimals, numbers that you 2.5, 28.6, 2.86665, 2888.5678. Floating point numbers, okay? And there are two types, floats and doubles. We've talked about both of them. And these are the ranges. We mentioned the other one in the previous video, and this is how you'd use them. All right. Now, I just wanted to mention a few things. If you wanted to, for example, store floating point literals or values in variables, and you wanted to, let's say, store monetary values. For example, if you wanted to store, let's say, money in your bank account. If you wanted to store that in your variable, you can just create a variable. You can just call it double my money, and then you can say that's equal to. You would be tempted to store it this way: 1,234,675.00. Assuming you had $1 million in your account, let's say $1.2 million, basically this value. You'll be tempted to store this in the variable this way. Anytime you're storing floating point numbers, or basically any number in Java in general, you don't use commas to separate them. If you wanted to store a number like this, just remove the commas. You never add commas. Store it this way, and that'll be just fine. And so when I compile this, oh sorry, I forgot to terminate it, and so it's telling me a semicolon is expected at the end, and so I just added it. When you compile this, now it's working. Okay, so don't add commas into your numbers. Just write them without the commas. Okay, this is a period and not a comma, so that's going to work. It's going to see this as a floating point number, in this case a double, and so we can store this number in a double. By default, remember we said Java sees floating point numbers as doubles, but because this variable is declared as a double, it has no problem storing this number in here. We created this variable as a float, and we're trying to store a valid number, although it was a valid number in here, which we're trying to store a valid number in it. But the thing is, Java sees all floating point literals. Anytime you write a floating point number in Java, it sees it as a double first, and so it's complaining and saying that, hey, this double can't fit in a float because it's up. Basically, you're storing something that can't fit in a float because a float has a specific size and a double has a specific size. So please make sure that this can fit in that make sure it's of the same type so it can fit in float. So you tell Java that, okay, don't see this number, even though this number is a valid number that can be stored in float, don't see this number as a double, okay? See it as a float. And so you do that with the letter F. So I don't know why by default it does that. I'm sure it has a good reason to do that. But that's how it works, okay? So in case you have a problem like that, this is how you'd take care of it. So when I compile this, now it works. Don't use commas like I mentioned, and it's fine. And you can actually, display this if you want it also. All right. So yeah, so that's it for a float, and that's it for floating point numbers in general, both doubles and floats. All right. Thank you very much for watching. If you have any questions, please comment down below, and I'll do everything to respond to them. Take care of yourselves, and I'll see you next time with the next video. All right then. Bye bye.